morning. Today we're going to talk about 1.4 functions. Okay, the introduction to functions and function notation. A relation is a mathematical term for such a row of coordinates, or also known in Algebra 1 was a set of ordered pairs. Okay? A function from set A to set B is a relation that assigns each element in the set A to exactly one element y in set B. Okay. In other words, what that means to be a function, your x coordinates cannot repeat. Okay. So set A is your domain, your inputs of the function, and set B is your range, which is also known as the outputs, which is your y. Okay. All right, characteristics to be a function. Each element in A must be matched with an element in B. Some elements in B may not be matched with an element in A. Two or more elements in A may be matched with the same element in B. And an element in A, the domain, cannot be matched with two different elements in B. And what I said before is that domain, that x value, cannot repeat. Okay. There are four ways to represent a function. Okay. The first way is verbally by a sentence. We can look at it numerically, which is just a table. Graphically by points on a coordinate plane. Okay. And then algebraically by an equation. Okay. So example 1, determine whether the relation represents y as a function of x. Okay, so the input value x is the number of representations from a state, and the output value y is the number of senators. This here is a verbal, okay, and this one does represent a function. Okay, so it does. And why does it? Is because regardless of my x value, the representatives from my state, the value of y is always going to be 2. So your senators is always going to be 2. So no matter how many numbers we have of representatives from a state, which is, and then y, we always have 2. So this one does represent a function. Okay. B. Now we're looking at a table here, okay? As we look at the table, we're going to look at our x values. So 2 corresponds with 11, 2 corresponds with 10, 3 corresponds with 8, 4 and 5, 5 and 1, okay? As I look at this table, you notice 2, my x value, my input, corresponds to 2 different numbers. So this one is not a function, and it's not a function because the input actually corresponds with 2 output numbers. It repeats. Okay. And then C here is a graph, okay, of points. And if you look at all of our points, okay, our x values do not repeat, okay? Our x values do not repeat. Okay, also it passes that vertical line test that you learned back in Algebra 1, okay? So this one does represent a function or is a function because your x coordinates do not repeat. Okay, and also if I would actually connect these points, we would end up getting a parabola, and we know a parabola is also a function. All right, example 2, determine whether each equation represents y as a function of x. Okay, so if we're looking at an equation, okay, we always want our equations to be y equals something, okay? Always look at based off of y. So let's go ahead and solve for y here, okay? So to solve for y, we're going to move the x squared to the other side, and we do that by subtracting it. So we get y equals 1 minus x squared, or negative x squared plus 1. Okay? So now think about this graph. We have a exponent of 2, a degree of 2, so we know this is a quadratic function. And this quadratic opens downwards, okay, because a is negative. So since this is a quadratic function, this equation is a function. Okay. All right, B, solving for y. Now we have y squared. So let's still solve for y. So how do I move x to the other side? I'm going to add it. So I get y squared equals x plus 1. And then to get rid of a square, we take the square root of both sides. And since we're taking the square root, we know we have two answers. So y would equal plus or minus the square root of x plus 1. Okay. Now, if that was just y equals the square root of x plus 1, we know that is a graph that goes in this direction. Okay? Because if I plug in 0, 0 plus 1 is 1, the square root of 1 is 1. Okay? If I plug in 3, 3 plus 1 is 4, square root of 4 is 2, so we'd have 3, 2. Now, because we have this negative, it also reflects it and goes in this direction. So if I plug in 3 now, 3 plus 1 is 2, but now we also have the negative 2. Okay? So if we look at this, our x value now has two values. Okay, repeating, so this one is not a function. Okay, it's not a function. All right, example 3, let g of x equal negative x squared plus 4x plus 1. This is just function notation, okay? And we know g of x just represents y, okay? So if I look at g of 2, this is like g of x. So what it's saying is my x coordinate is 2. My x coordinate is 2. So it's saying evaluate y or g of x when x equals 2. So all we're going to do is plug in 2 into this problem. So g of 2 would equal negative x squared plus 4 times x plus 1. And we're replacing 2 for x. Okay? So following orders of operation, 2 squared is 4. And I'm going to go ahead and multiply this plus 1. So we have negative 4 plus 8 plus 1. So we get 4 plus 1, which is 5. So y is 2, or excuse me, y is 5 when x is 2. Okay? Now looking at part B, now it's saying x is equal to t. So we're just replacing x with t now. Okay? So we have g of t would equal negative t squared plus 4 times t plus 1. So this one's pretty easy because t squared, negative, so it's just negative t squared plus 4t plus 1 because we can't combine like terms there. So that's evaluated when x is t. Okay. And then the last one here, when x equals x plus 2. This one's a little bit more challenging. So we're plugging x plus 2 in for x. We have negative x plus 2 squared plus 4 times x plus 2 plus 1. So here when we have x plus 2 squared, remember that's x plus 2 times x plus 2, and we actually have to FOIL that. Okay, so we get negative x squared plus 2x, which is 4x, plus 4. Then here we're going to distribute. So we get 4x plus 8 plus 1. Now we have to distribute this negative through. Okay, so negative x squared, negative 4x, negative 4, and then we have the plus 4x plus 8 plus 1. And then we're going to go ahead and combine like terms. So x squared is by itself. We have a negative 4x and a positive 4x, which cancel out. And then we have a negative 4, a negative or a positive 8, and a positive 1. So negative 4 plus 8 is 4. 4 plus 1 is 5. So G evaluated at x plus 2 is equal to negative x squared plus 5. Right, evaluate the function when x is -1, x is 0, and x is 1. So here we have some restrictions. Okay, we have x is less than 0, x is greater than or equal to 0. When x equals -1, could we put x equals -1 in the first equation? Yes, because it says x is less than 0 and -1 is less than 0. So we're going to evaluate when x is -1 for x squared. So we have x squared plus 1. So we're going to do -1 squared plus 1. -1 squared is 1. 1 plus 1 is 2. So when x is -1, we get 2. Okay. Looking at the next one, when x equals 0. Well, can we look at the first one? X is less than 0. No, because it's saying x is less than, so it has to be -1, -2, -3, and so on. Okay. X is greater than or equal to 0. Yes, because it's equal to. So we're going to evaluate with the equation of x minus 1. So 0 minus 1 is -1. And then when x is 1. So will we use the first equation? No, because 1 is greater than 0. So we will use the second one again. So plugging in 1, 1 minus 1 is 0. And there you go. So make sure you classify which one you're supposed to use. All right. Find all real values of x for which f of x equals 0. So now it's saying for which f of x equals 0. So that means y equals 0. So we're going to plug 0 in for y in this case. So f of x represents y, so that'd be 0 equals -2x plus 10. And now we're going to solve for x. So subtract the 10 over, we get -10 equals -2x. Divide by -2, and we get 5. So when y is 0, x is 5. Okay. All right, in part B, same idea. F of x is y, so y is 0 equals x squared minus 5x plus 6. Now, since this is quadratic, we have to look at, can we factor it? Can we use the quadratic formula? Can we complete the square? Any method you want here. I'm going to try to factor since a is 1. Okay, so x times x. What times what is a positive? That adds be a -5, so 2 negatives. We have a -3 and a -2. Now we factored it, but we haven't solved it yet. And since we have a equal sign, we actually have to solve. So we're going to take x minus 3 equals 0 and x minus 2 equals 0. So x would equal 3 and x would equal 2. So x could have 2 values when y is 0. All right. Example 6. Okay. Find the values of x for which f of x equals g of x. So now we want the function to be equal to each other. Okay. So if I look at part A, what is f of x? F of x equals x squared plus 1 equals, well, what's g of x? 3x minus x squared. Okay. So now let's get our x squareds on the same side. Let's set this equation equal to 0. So I'm going to add the x squared. So I'm going to get 2x squared, bring the 3x over, so minus 3x plus 1 equals 0. So then for this one, I would try to factor again. Okay. I put a 10 there, sorry, equal. Okay. So let's go ahead and factor. So we have 2x and x, 1 and 1, and they need to be negatives. Okay. Now set each group equal to 0. So we have 2x minus 1 equals 0 and x minus 1 equals 0. So x would equal 1/2 and x would equal 1. So the x's need to be 1/2 or 1 to see when f of x would equal g of x. Okay. Let's do the exact same thing for part B. So my f of x is x squared minus 1 equals my g of x is negative x squared plus x plus 2. Bring our x squared over, so I'm going to add it. So that would be 2x squared again. Subtract my x over. Subtract my 2 over minus 3 equals 0. So then once again, I'm going to try to factor this. So 2x and 1 and x. We need a positive and a negative, and 3 and 1. So we'll do 3 and 1 here. We need a negative 1, so we need the negative 3. All right, and now we solve. So 2x minus 3 equals 0, and x plus 1 equals 0. So when I go to solve for x, we get x equals negative 1 for this one. Add 3, so we get 2x equals 3. Divide by 2, so x would equal 3 over 2. So we know when x is 3 over 2 or negative 1, f of x would equal g of x. All right, the domain of a function. Okay, the implied domain is the set of all real numbers for which the expression is defined. Okay, so again, domain are your x values. Okay, so as I look for a here, since a is just a relation, we just have to list our x values for my domain. So my domain would equal, my first x value is negative 3. My second x value is negative 1, 0, 2, and 4. Okay. All right, so B now, this is a polynomial, so we know it's going to be all real numbers. However, we have this denominator, okay? So we have to set that equal to 0 because your denominator can never be 0. So when I subtract 5, I get x equals negative 5. So x cannot equal negative 5. So it's going to be all real numbers except for negative 5. Okay. So part B is the volume of a sphere. V equals 4/3 pi r cubed. When we're talking about volume, okay, volume is that space inside of my sphere, right? The space inside. So if it's talking about the space inside, we know it has to be positive numbers. We can't have a negative volume from that, okay? So since we're looking at a polynomial, we know it's going to be all real numbers, except we can't include negative numbers because volume has to be positive, okay? So we're going to say all real numbers are, since we're talking about the radius, such that r is greater than 0 because we don't want to include negative numbers for my radius because especially when I cube it, it would stay negative, okay? All right, part D, it's a quadratic, or excuse me, it's a square root. So we know normally it's going in this direction, right? Okay. But because we have this minus 3x here, we know it's going in this direction away. So we know our x values, or my y values, or excuse me, my x values are going to be negative to make this a positive number on the inside, okay? So since we're going in this direction for my x values, we know it's going towards negative infinity, goes towards negative infinity, but we need to figure out where is this coordinate here? Where is that starting point? So to get that starting point, once again, we have to set the underneath the radicand equal to 0 and solve, okay? So we're going to subtract the 4, divide by 3, so we get 4/3. Now, can x be 4/3? Yes, it can, because when I plug in, we get 0, and the square root of 0 is 0. We can actually take the square root of it, so we will include that number there, okay? Alrighty, so let's look at some application problems. You work in the marketing department of a soft drink company and are experimenting with a new can for iced tea that is slightly narrower and taller than the standard can. For you, the experimental can, the ratio of the height to the radius is 4. Write the volume of the can as a function of the radius r, okay? So let's think of the volume of a can, okay, or a cylinder. So the volume of a cylinder is volume equals pi r squared h, okay? So now we want to write this with the radius r. So I'm going to keep r in my equation. We just need to change my height to something in radius, okay? So we know that if you look at the diagram here, h divided by r equals 4. So if I'm solving for h, I would multiply by r, so h would equal 4 times r. So my h I'm going to replace with 4r, and now I'm going to solve. Okay, so 4 times pi is 4 pi. R squared times r would be r cubed. So the volume in the function for radius r is 4 pi r cubed. Okay. Now b, we're writing it for height h. So now we're keeping the h in there. Okay, so let's start back with my original problem. So we're keeping h, so now I have to replace r with something in terms of h. So coming back up here, okay, we know h equals 4. So coming back up here, h equals 4r. How do I solve for r? I'm going to divide by 4. So my r is h over 4. So now I'm going to replace r with h over 4. Okay, so now orders of operations say I'm going to square that first. So h squared over 16 times h. And now let's simplify a little bit. So h times h is h cubed times pi. So I'll put pi in front and then divided by 16. So the volume in terms of h is pi h cubed divided by 16. Okay. Number 9, a batter hits a baseball at a point 3 feet above ground at the velocity of 100 feet per second and an angle of 45 degrees. The path of the baseball is given by the function of f of x equals negative 0.33 or 0032 x squared plus x plus 3. So we know it's a parabola there, right? So it's quadratic. Where f of x is the height of the baseball and x is the horizontal distance from home plate. Will the baseball clear a 10-foot fence located 3 feet from home plate? Okay, so we want to look at what is the height, okay, located at 3 feet from the distance, okay? So if we look at, I'm going to plug 300 into my x. So we're going to put f of x equals negative 0.0032 times 300 squared plus 300 plus 3. Okay. Then using my distance, we end up getting 15. Okay. So my baseball is 300 feet away from home plate. We will be at the height of 15. So if we have a height of 15 at 300 feet, will we clear a 10-foot fence? Yes, we will. Okay. So yes, we would be able to clear. Okay. All right.